Okay, yeah.
So
Go ahead.
would it be 6,440 meters?
Yes, that is correct. 6,440 meters, 2.51 meters per second. If you do an algebraic if you just do a little algebraic manipulation with the units here, meters over meters per second, um, you'll see that you get meters over seconds times over meters, and then you're left with seconds. So we can prove that indeed distance divided by speed or velocity is equal to time. So now that we have that, we have T1. This fool walks 6.44 kilometers. That's crazy. Let me see. Six. Damn. I walked for 42 minutes. That's crazy. Okay, so what is T1 if you calculated it?
Uh, 6,440.
2,565.737.
Nah,
Yeah.
Valeria. Okay. 2,565. Valeria, I know you're good with the sig figs. Um, Matthew, how many sig figs
Yeah.
will the time have?
Is it just three
Yes, that is correct. How'd you come up with three?
or yeah? Because that was the least amount in the initial question.
What do you mean here?
Oh, there. Yeah.
Yeah,
Sorry.
you would use here, not up here. You, whatever calculations you're doing, that's where you.
Okay.
So 2,565. If we're rounding to three sig figs, what number is that? Not
565. 57. 2,570.
okay. Awesome. Okay. Making sure you know how to round. If you don't know how to round, you would definitely mess up somewhere. Okay, so
Yeah.
now this is not meters. This is seconds. So now we have
Seconds.
T1, and I'm going to delete all of this here and store T1 in this corner. So now we got that. We have T1, which we can replace with the number 2,570. So now we're looking for two variables here, x, which is tied to T2, x over T2. We're looking for those. Any ideas on how to find it?
Mm. We would have to do the change in uh displacement over time again, but this time using the 0.49 meters per second and the x.
Okay, okay. This will, what did you say?
Uh, oh wait, we'd have to use the 0.49 meters per second.
0.49. Okay. Um, I okay. The way that I'm understanding this, I would use this, but to reduce the number of variables here. Uh, and it's okay if you don't understand what I'm going to do here. Honestly, I don't understand why this problem is so difficult. And we only went over this once, even hard, pretty early. Um, so the distance x2, which is the distance traveled over this average velocity, is going to be equal to, what would this x2 be equal to?
Um,
Okay,
The velocity of
say that again.
second velocity. V2,
Yes. V2, and then we're just trying to reduce the number of variables here. So the only other variable we have to use here is T2.
let's use the T2. So T2 is 2,570.
No, that's T1. T1 is how long it took you from get from point A to point B. We're looking from point B to point C. We don't know how long it took us, how long we were walking this distance, but this will give us that value. By doing that, yeah, is equal to this, this distance, yeah, 6,400. But that distance, first distance, 6,440, plus the distance that's covered the second time over the total time. What is that equal to? Just the concept. What is it equal to? Speed, distance, time? What is it equal to?
what was the question?
Okay, so if you're dividing this, which is the first distance, or the distance covered the first time, plus the distance covered the second time, I mean, the displacement covered the first time, plus the displacement covered the second time. That's going to be what? What is this right here? This top part. It's going to be either this,
The distance? Uh, um, is it just gonna be a displacement?
Yeah, it's going to be just displacement. This is going to be just displacement. This bottom part is going to be just what?
The time.
Right, that is correct. That's going to be equal to your velocity, what?
Is it the overall I mean, yeah,
That is
the
average
overall average
velocity.
velocity.
That is correct. It is going to be the overall average velocity. So this is going to be equal to 3.136 meters per second west. So If it's due west, would this be positive or negative?
Negative.
Right. Okay, so now that we have everything defined in terms of one variable, we'll try to isolate this part right here. This is where your algebraic skills will come into play. Okay, so I'm going to manipulate this. Have any questions as to why I did what I did? You stop me. So 2,570 seconds plus C2, multiplying both sides by it. Multiply both sides by it. And I'll get rid of this bottom part. We'll have this over here. And then once we have that, we're going to do left with 2,570 seconds. 2 times negative 1.36 per second. It's equal to 6,440 meters plus 0.49 meters per second. Okay. Meter per second times T2. And what we will do from here is multiply this out. I hope you can see why this question is quite complicated.
It's hard because the question is like, it's like reverse engineering of what we're learning right now, sort of.
Yeah, you need a very deep understanding of displacements and the formulas for displacement, stuff like that. So we're going to get negative 3,495 minus 1.36 T2 is going to be equal to this number right here, 1,440 meters plus 0.49 T2. Now we just solve for T2. 5.2. So 934.8 is equal to 1.85 T2. Okay, now given this, what is T2? Go ahead and calculate it. You got the answer, feel free to shout it out.
Oh. Is it 1,591? Or I don't know if that's right.
That is correct. That is correct. How many significant figures would it have?
Oh dang, I don't know actually.
Quite a
Would
complicated.
it just be 3?
Yeah, let's just limit it to 3 for the sake of this question, because the question only has 3 significant figures for everything. But the limit is just 3. 1,590
0. Yeah.
That is the time for us to go from point B to point C. Okay, so now we have the velocity that we traveled to the left with, the time that we traveled to the left with, along with the velocity that we traveled to the right with, and the time that we traveled to the right with. And we're looking for how far did we walk. Can you see how we can use that information to calculate how far we walked?
T2. Wait. Oh yeah. Wait. You had the 2 times together,
Hmm?
or
I think the hard thing here is we have to do some math calculation, right? Algebra
Yeah,
algebra calculation, right?
manipulation.
Oh
Yeah.
my God. Yes.
I don't know how you figured this out in an hour if you didn't already know how to do that, to be honest. Let's see. Okay, so we are looking for how far did we walk. So what information do we have? What information do we have? Just, do we have velocity? Or we do have velocity the first time. Velocity 1 is equal to 2.51 meters per second. Velocity 2 is equal to 1.36 meters per second. I need to write it down the direction too. West, this is incorrect. That is correct. That is correct. No, you said something earlier, Matt, and that is correct. T1, we have T1, we have T2, which is going to be equal to the total
Yeah.
amount we took. Okay, so what do we do with this total time?
I think you plug it into the formula that we were using earlier. The change, the
Oh, wait. Pause.
displacement.
No, we're wrong. That will give you the distance we traveled
Oh,
in a direction because this is velocity. You're asking for distance. So we walk this way in some speed.
yeah. Wait, so we have to add. Wait.
We walked this way with some speed, v1, and some time. And then we walked, but we also have the distance. So we walked, and we walked this way with some speed and with some velocity. Something decided.
So we're supposed to add the 2 distances. I mean, the 2 displacements together
Yeah, basically, if
to
you add
find
the
the
two
total
displacements,
distance.
yeah, if you add the 2 displacements, then you'll get distance. But remember, you're not looking for displacement. You're looking for the distances that they covered. So it'd be v1 times t1, because velocity is meters per second times some time is equal to meters distance. So v1 multiplied by v2, v1 multiplied by t1 is going to give you d1, which we already have. We don't really need that. You're going to take the absolute value of this. The reason why is because this is 2.51 east, and the velocity is negative because of that. So the distance is always positive. Do not be adding negative distances to find total.
Yeah.
Correct. So we have V1, T1, take the absolute value of that. And V2 times T2, absolute value of that. And the total distance is just going to be equal to V1 plus V2.
Yeah.
Hopefully we did it correctly. The answer is correct. Now if you have the answer, if you know you're going to struggle on this question, do try it again. See if you can try to come to the same conclusion every time.
Wait, so what would the answer be if it's?
Hmm?
What would the answer be?
That's a question I should ask you. What do you think the answer would be based off of these?
Oh, okay. V1, wait, V2. T2. 1,590 seconds. And notes are everywhere.
You're good. You got an answer yet?
Uh, oh, not yet. Times T. 6,000. I think I'm doing it wrong. I don't.
Go ahead and explain to me what you're doing.
I'm trying to add the V1. I mean, I'm trying to multiply V1 and T1.
Okay.
And wait. Oh no, I was using the wrong. I was using displacement instead of velocity. Right, so 2.51 meters per second times the 2,570 seconds
That
to
would
find the D1.
yeah, that would be correct.
Okay. I was using the wrong numbers because I was, yeah. gonna be 6,450.7 meters. Okay, I see. And then you just add the 6,450.7 plus the 779.1.
What did you say?
You add those two numbers, the 6,450 and the 779.1.
Well, you wouldn't subtract them. I don't know what number you would get from there. Actually, you would get displacement from that.
7,229.8. And that would just be distance, so it's not like positive or negative.
Well, it is positive. How
Oh,
many
yeah.
sequences are we going to be?
It can't be negative. It's just distance. Yeah.
How many sequences are we going to have? You hear me?
What was that? Sorry.
How many significant figures are we going to have?
Oh. Would it just be 3 again?
That is correct.
Or yeah.
That's correct. Okay. So it's going to be 3, which makes this 7,730 meters. Hopefully that answer
Yeah.
is correct. As I said, I don't have access to Cengage, so we're going to move on to the next question. Hopefully it will be easier. We took an entire hour to answer that one.
Yeah.
So, 2. Nobody else submitted a question, so we're going to keep going. Your second question. Yeah. Okay. I'm gonna need to copy this.
No, it was wrong. I checked.
Yeah.
Yeah, I don't know.
Let's see. Lily, did you get the question correct?
Yes, I did.
Okay, do you remember what answer you got?
Oh.
So, because we have the different answer, like different question. So on the Cengage,
Oh,
we
okay.
have different question, like
Understood.
also with the same question and different number.
No, I understand.
Oh.
That's unfortunate.
Oh yeah, so you have to figure out by yourself.
Okay, understood.
And remember to round up too. You have to round up every single number,
Round every
like
single-
significant number and round it up. Yeah, every
Okay.
number to get it correct.
Oh.
Perhaps we missed a rounding somewhere.
Yeah, that's probably what it was.
So I think if you know how to do this question, just go back later to figure out. Do some calculation later.
Yeah.
Like if you want. Can I ask a question?
Go ahead.
Yes. So I just want to confirm: is it average velocity equal to displacement divided for time? So
That is
I
correct.
just saw it yeah, that's correct. So can you explain a little bit about displacement again?
Okay, no problem. No problem. I will explain that before I start
Yeah.
working on this one. Okay,
Yeah,
have
sure.
you- Okay, so displacement is hmm, I guess you can see it as a distance relative to a point. So if you started, for example, you're in the middle here, right? And you walk this way, 4 meters. Your displacement at this point is 4 meters from the center. But if you walk this way, you are at the point 2 meters. Now you are 2 meters away from the center. But you walked in total 4 plus 2 meters, which is 6 meters. You walked a total of 6 meters. So that's the difference between displacement and distance. Also, a important difference is that distance will never be negative. It is, as I just described, it's additive. So we added 4 meters to 2 meters because direction does not matter. Therefore, it does not have a negative value at any point. It's just the distance you covered. It's a scalar quantity. Yeah. But displacement is going to be relative to a point and is going to have a direction. So if you walked 4 meters this way, displacement is 4 meters to the right, east, whatever you want to use, but it is a scalar. Do you remember what the other kind of units are? Forgot what the name was. It's not scalar. It's
Oh, I see. I see. So
vector.
normally if it's asking, yeah, if it's asking about average, we should be use the displacement, right? Because like some of the question I see different. Some are just asking velocity and some asking about average. So sometimes I'm confused.
Okay. So velocity always uses displacement. As I said, velocity is a vector, same as displacement is a vector. Displacement is a vector. So it's going to use displacement because this one's a vector. This one is a vector. Velocity, same as displacement, has a direction. So if you walk this way 4 meters in 2 seconds, you have your velocity in this direction. But for speed, it is not a vector, it is a scalar quantity. It's not positive, it's not negative. So you're going to be using just distance over time because distance by itself is a scalar quantity. Velocity this way, we move this way, then we move this way. 4 meters in 2 seconds and 2 meters in 2 seconds. Four meters in 2 seconds.
I see. Thank you.
Okay, you understand? Okay, good. Awesome. All right, let's go back to the question.
Yes, I understand.
Okay, awesome. So, an Olympic class sprinter starts a race with an acceleration of 4.48 meters per second squared. What is her speed in meters per second after 1.84 seconds? Okay. So, this will require you to understand what the concept of acceleration is, and two, what are the formulas called? Your kinematic equations are. Okay. Matthew, can you describe to me a situation where you would be accelerating? Give me any example.
Is it when we increase is it when we on the way with the constant velocity and we
No.
increase the speed, right? No.
Constant velocity suggests that there is no acceleration. For example, if you're driving in your car and you're going at 60 miles an hour the entire time, are you accelerating?
No.
That's right. That's because your velocity is constant. There is no change in velocity. The change in velocity is
So
acceleration.
so maybe acceleration is the change of speed, right? The change of speed.
It is the change of speed or velocity. It is
Yes.
the change of either, depending on the context. Um, yeah. It's going to be the change of speed. So it's going to be the change of speed over a certain time. Same way as we have instantaneous velocity, we have instantaneous acceleration. Same way as we have average velocity, we have average acceleration. So real quick, Lily, can you describe to me an instance where we would be dealing with instantaneous velocity?
Oh, I don't remember.
Okay. Instantaneous velocity is your velocity at a specific moment in time. At a very specific moment in time. If you are falling, right? If you're falling down a cliff, God forbid, and you're at this point, right? Started here, you're not falling. You're here, you're falling slightly faster. And then down here, you're falling even faster, and so on. Your velocity at a given moment in time, say t equals 3 seconds, that's instantaneous velocity. At this instant of time, instantaneous velocity.
Okay. So it's more like a snapshot of
Exactly. It
like
is
a
exactly a
curve on a
snapshot.
graph.
That is
Okay.
exactly a snapshot. In terms of graphs, if you're dealing with this, and this is acceleration, and this is, oh, let's not go into that. I'm going to describe that. That's going to be the second part.
Okay.
But yeah, it is a snapshot. That is what instantaneous is at a given instant. There is no change in time. But for average, that's going to be dealing with a change in time. For example, if your acceleration at this point is 4 meters a second squared, the reason it is second squared is velocity. Velocity is meters per second, right? The change in velocity over time, over a given time, is acceleration. So we have this velocity divided by time, which is seconds, which is going to give you meters per second squared. Meters per second times second, meters per second squared. That's what it's called. That's why the units are those units. Okay, so at this given instance, you are falling at 4 meters per second squared. And at this given instance, you are falling at, let me go back. Not meters per second squared. You are falling at 4 meters per second. And at this instance, you are falling at 8 meters per second. Okay, so can you, Matthew, if you can recall, can you give me the formula for change in change in velocity? No, can you give me the formula for acceleration?
Uh, sure. It's change in velocity over a change in time.
That is correct. Change in velocity over change in time. That is going to be the formula for acceleration. And we have the velocities here. So we're going to have the final velocity minus the initial velocity over the time that it took. Let's say it took us 3 seconds in these points. It's going to take us 3 seconds, and we're going to end up with 3 meters per second squared. This is going to be the acceleration. And this is average acceleration because it deals with a change in time. As you can see, at this given point, we are falling some acceleration. At this point, we may not be falling the same acceleration, but because we use time and we use the change in velocity to calculate the acceleration, is average acceleration, not instantaneous. It's a snapshot. Okay, so now that we understand acceleration, let's just an Olympic sprinter starts a race with an acceleration of 4.48 meters per second squared. We're making the assumption here that this is constant throughout this period of time. Can you infer what we're going to do with these two numbers to calculate her speed? Lily. Okay. If it's inconvenient for you to talk, don't worry. I'll give you 5 seconds. Okay, Matthew, can you infer what we're going to do with these two numbers that they gave us
To
to find speed?
I mean, so it's asking what is her speed 1.84 seconds later, which means that she started at a certain speed and it's sort of like it's asking at 1.84 seconds, so it would be at a specific speed at that time. So it's asking for the snapshot, like it's asking for the what is it called? We were just talking about it. Oh yeah, instantaneous velocity.
Yes, that is correct. That is correct. I like your thought process. That is, in this case, let me not dive into it too much, but this will just boil down to, okay, so if you're in a car, right? Your car is accelerating. Your car, in this case, we're going to equate it to this case. Olympic sprinter starts a race. At the beginning of a race, are you moving?
No.
No, you're not moving. So we know that at the beginning of the race, your velocity is going to be equal to 0, and your car, you floor it, and your car is accelerating at a constant acceleration of 2 meters per second squared. How fast will you be going 2 seconds from now? Actually, let's make it 3 seconds from now. Can you guess?
Oh, it's accelerating at a rate of 2 meters per second squared.
Mm-hmm. That means its velocity.
Okay, that makes more sense.
At this rate.
At that rate, each 2 meters each second. So in 3 seconds, it would be to 6 meters.
That is correct. If you write down the units, meters per second squared times 3 seconds, and we're just dealing with just the units, we have meters per second squared times seconds. This cancels out one of these s's, and then we end up with this meter per second. So we can prove that acceleration times time is equal to a velocity or speed. So, in other words, velocity final is equal to our velocity initial, which was 0 at this instance. Velocity initial plus acceleration times time, given that acceleration is constant. This is one of your kinematic formulas that I was talking about.
Okay.
Mm-hmm. And Just some
Wait, you said
advice. Go ahead.
in the event that acceleration is constant, so
Yeah.
acceleration can be variable.
Okay, acceleration can be variable.
could
When
be
you're
like in the
accelerating,
future, I
when you're
guess.
flooring your car, right? Your acceleration isn't going to be constant. That's why your time between
Yeah,
0 and 30 miles an hour versus 30 miles an hour to 60 miles an hour, it's not the same. That's because you're accelerating slower as you go faster, and the acceleration is not constant.
yeah. Okay, that makes sense.
Yes. Okay, so now that we have this understanding of acceleration, can you infer what we're going to, uh, can you tell me what her speed is at 1.84 seconds?
0.48 seconds. It would be like around 7 meters per second. I'm not sure.
You have a calculator there,
It's asking for the speed. Yeah,
then use it.
yeah. Wait. Um, I forget what I'm supposed to do here
You
in
remember the
algebra
kinematic?
manipulation.
Look at the, see if you can recall the formula.
Final velocity equals initial velocity plus acceleration times time.
Mhm. Plug in the numbers there, you should get the final velocity.
Okay. Initial velocity 0. So it'd be 8.24.
That is correct, 8.24 meters per second. Meters per second. So
Okay.
let me give you different numbers. If you have 3 meters per second squared, and you're accelerating for, what is your speed at 10 seconds?
Mm, you said 3 meters. Would it just be 30?
30, 30, that is correct. 30 what?
Meters per second.
That is correct. That is correct. Mundo. Okay, so, okay, now we get to the difficult part, which is sketch a graph of position versus time for this period. Okay, so let's sketch a graph for velocity. Let's sketch a graph for velocity. Velocity, no, yeah, velocity, no. This is time, this is velocity. Time versus velocity. So at 1.84 seconds, we have this point, and we're going to write down that number that we got. What was it, 8 point something?
8.243.
8.243. Okay, so I'll do 8.24 meters per second. Okay, what was her velocity at t equals 0?
Sorry.
Not her. Yeah, her. Yeah, what was her velocity at t equals 0 when at the very beginning of the race?
Is 0?
That is correct. It was 0. Now, what was her velocity at 1.84 seconds?
Mm, would it be 8.24
That is
meters per
correct.
second?
It is 8.24 meters per second. So if we draw a line, connect these dots, we get this graph. Ignore the fact that I missed the dot completely. We get this graph, and it's linear because the change in acceleration is constant. So now we are going to, this is velocity versus time. Now we're going to go distance versus time, which is where this gets pretty difficult. See, okay. Okay. In order to do this, you would need to, over time, you'll be able to look at this and know which graph to choose based off of patterns, based off of the way acceleration affects distance. But for right now, I want you to calculate and prove what shape the acceleration causes the distance to have. In order to do that, you need one of the kinematic formulas, which will be do you have your kinematic equations on you?
Yeah.
Okay.
Mm,
Sam to me.
Wait. Oh, I'm not sure if these are the right ones. Hold on. Wait, x equals. Hold up. I don't know how to type that out.
You're okay. You just need to describe it to me. You don't need to type it out.
One of them is x equals x like 0 or like the little, I don't know what it's called, naught or something,
Yeah, it's x naught.
or x naught. Okay, yeah, x naught plus v naught times time plus uh 1/2 times acceleration times time squared.
I'm sure that's correct.
Yeah.
Yeah, okay. Let's see. Yeah, this is correct. This is longer than I'm used to remembering it, but yeah, this is correct. The final position. That's all right. Hit me with another. Hit me with another kinematic equation.
Uh, let's see. Is acceleration one of them? Or no?
Just whatever you have written down. Go ahead and.
Uh, v equals v naught plus acceleration times time.
Huh?
Plus acceleration
Okay.
times time,
Okay.
and that's supposed to be equated to y equals mx plus b.
In for y equals mx plus b for a velocity time graph, yes.
Okay. Yeah.
In this case, what would m be? What would the slope be in this formula?
It'd be v naught,
No.
or would it be acceleration times time?
That'll be acceleration times time is mx, yes. But which one of these are m? Which one is the slope?
Would it not be V naught or would it
V
be
naught, for example,
acceleration?
which is our initial acceleration, which is here, is the y-intercept.
Oh, the slope is velocity, right?
Velocity? You're not, maybe, no, it's not velocity.
No. Uh,
In this case, it would be, okay, so at this point, yeah, we are at 0 meters, and that is going to be our velocity initial, which is our y-intercept. My y-intercept is going to be 0 comma b.
what?
So
Oh,
this is mx. So which
okay.
one is
Oh, it's because in the notes I guess I equated the wrong ones. Like I mismatched them. I didn't write it down right.
You could just make sure you rewrite them because these formulas are very, very important.
Okay. So wait. I have to look at the class notes because I wrote it down wrong. So I'm pulling it up right now.
Well, if you don't want to look at the class notes, I can go ahead and write them down here. You have some of them. I'll go ahead and give you the rest. V final squared is equal to velocity initial or not squared plus 2 times acceleration times distance. And then distance final is equal to 1/2 initial velocity, velocity naught plus final velocity times time. These are going to be the ones you're going to use the most.
Oh yeah, okay. I was looking at the wrong equations. That's why I didn't know it was those three.
You're okay. Don't
Okay.
worry. Don't worry. Live and we learn. So with all these equations, you might wonder why we need all these equations. They calculate some things, but 2 of these calculate velocity finals, 2 of them calculate position final. What's the use of having duplicates? And they are not duplicates. They just require different variables. So because sometimes you'll be given different concept, you'll be given different information. For example, you're given velocity, the initial velocity, the acceleration, and you're given the distance in which you're accelerating. You have initial velocity, acceleration, and acceleration, and you're given the distance. This one does not have the distance. You can't use it here. You'll be able to use this one to calculate your final velocity. So you'll need to look at these formulas, see what information you have, and try to plug it in to get the variable you want. Sometimes you'll be given final velocity, acceleration, and time, and you'll need to find initial velocity based off of that information. So it's not always, just know you're going to be using these formulas a lot. So get used to them. Make sure every time you do a question that requires them, try to recall all of them or write it down. That's how I started. So I memorized them. I'm not sure if she requires you all to memorize it, but it would be very beneficial for you to do that. Okay, so we are given acceleration and time. Acceleration, time, and we're given her initial velocity as well. What formulas could we use here? Acceleration, time, initial velocity.
Wait, what? Sorry. What was the question?
You're good. We're given her acceleration, her time, and her initial velocity. Which one of these formulas could we use? We name this 1, 2, 3, and 4. Just tell me which numbers we could use.
Uh, Would it be 2 or
Velocity initial,
no?
acceleration, and time. Yeah, we can use that to find, we can use that to find the final velocity, but we're looking for distance.
Oh,
Distance. Let's see. Second.
distance. Oh, the change in distance.
Actually, yeah. Okay, we have velocity initial, the acceleration, the time, and the final velocity.
Okay.
Uh,
So should we use the third? Wait, velocity final. The fourth one.
that is correct.
Is it
We're
the
going to be
fourth?
using the fourth one in this
Yeah.
case. Sometimes you're going to need to find, say, you are given some variables and you need to find x in order to use this formula. So you
Yeah.
need to use this formula to calculate x. Sometimes you're going to be using a combination of these formulas to find one piece of information. So get very comfortable with
Okay.
that. So distance final going to be equal to 1/2 the initial velocity. What's the initial velocity?
0.
That's correct. What is the final velocity?
Wait. The 4.48.
4.48. That is correct.
Oh no, no. Yeah.
Oh, no,
Okay.
that's incorrect.
Or is it the 8.24?
That is the final velocity. Yeah, that's correct. How much time did it take?
Yeah. 1.84 seconds.
1.84. Okay, so now we use this formula to calculate the distance. Go ahead and calculate the distance and come back to me.
Oh, okay.
Have it. I mean, not the, yeah, the distance. Come back to me when you have it.
Okay. Uh, 7.58
That is correct.
meters.
That distance is
Is
going
it?
to be 7.58. Okay, so now we're given this 7.58. And we know the distance at the very beginning is 0. You may make the assumption that it's like this, but I will tell you right now that is
Yeah.
incorrect. Let's go ahead and
Okay.
try. Uh, okay, so let's try to calculate her distance at 1 second.
Okay. 4.12.
That is no, that's not correct. That's not correct. I gave you.
Oh, it's not.
Yeah, don't worry. I gave you the time. You will need to.
Yeah.
Which formula did you use?
I used the same one. Was I not supposed to use the
Okay.
same one?
All right, let's see. Let's see what we let's see if we can find what you may have did wrong. We're looking for the final position,
Yeah.
given the initial velocity, which is 0, plus the final velocity at 1 second. What is the final velocity at 1 second? Is it
Oh,
still 8.24?
no. Okay, it's not. So you have to. Okay, I see. The wait.
Got that distance final yet?
Wait, not yet. Oops. 5, 8. Is it 3.79? I don't know if
Is
that's
that what you got
right.
for is that what you got for the final distance?
No.
What did you get?
Wait, hold on. I think I did it wrong.
Okay, so I will give you a hint. You will need to calculate the final velocity, new final velocity at 1 second, along with the distance. The new velocity at 1 second to calculate the new distance. This formula requires it.
I'm confused. I don't understand what I'm supposed to do.
It's okay. It's okay. At first, you won't know what to do because these problems, these are different from the kind of thinking we do on a daily basis. So don't worry.
Yeah.
With time and practice, a lot of practice, too much practice even, you'll be able to recognize the how to start a problem, how to get from one point to another. So do not feel defeated. You're not dumb. This stuff is just hard. Okay.
Yeah.
All right. So here we go. So firstly, we're looking for the distance at 1 second. To calculate distance, we have these formulas. You could possibly use this formula too. If you want to. So in order to calculate that, let's see. We'll stick with this one for right now. The bottom one. So to calculate the final distance, we need the initial velocity, which we have. The final velocity at 1 second, or the current velocity, whatever. And then the time, which is 1 second. We do not know what the velocity final, what the velocity at 1 second is. So we now look for a formula to find the velocity at 1 second. Which one of these formulas can we use?
Okay. You said we're trying to find the final velocity?
Yeah, we're trying to find the velocity at 1 second.
At 1 second. Okay, so the 3?
No.
Final
Ignore
velocity.
this. I ignore what this is. The acceleration is this.
Oh, wait. So we would use the first one?
The first formula.
Yeah.
You know what? Yeah, we can use that first one. Yeah, we can use the first formula to calculate the distance at that time.
But would it be the best one though, or is it
In this case, it would be the most convenient because for this one, we need the initial velocity, the final velocity, which we do not have,
yeah.
time, which we do have. So for this one, we have the initial position, initial velocity, time, acceleration, and the time. So this one is the most convenient.
Yeah. would it still give you the final velocity?
We do not need the final velocity. We're just looking for distance.
Oh, wait. I'm confused.
Well, we're using this formula up here.
Okay.
We're trying to find the distance at 1 second.
Oh, Lily said that she got kicked out of the call or the Zoom. So I don't know if he wants to get back in or not.
Just keep working on that. I'll try to solve the issue.
I was thinking, why don't we use the second one, the second equation, because we're looking for final velocity already, and that's like what it's looking for. Or is
Give me a second. Say that again.
the second equation?
The second. What did you say about it?
Should we use that one instead? Like, because I'm not sure if
What's wrong with the first equation?
because it doesn't have final velocity in it,
We don't need final velocity.
or like, but that's what we're supposed to look for, right?
We're plotting this graph right here, which is distance versus time. We don't need the final velocity. We're looking for distance. So if we can get straight to the distance, which we can here, that's what we're looking for. We don't need the final velocity.
Oh, okay. Yeah, I still don't understand.
Okay. So what do you not understand?
Okay, we're supposed to find. You said like what if we change the time to 1 second instead of 1.84, right? That would change the final distance
Let's change both the final distance and the final velocity. Yeah.
and the final velocity.
Yeah, it'll change both.
Okay, so we'd have to find at least one of them with one of the equations that are up there, right?
Yeah. Okay, we're looking for final distance. So look for the
Okay.
equation to find final distance. And we have, well, three equations we could use because there's distance here, and distance here.
There's distance there, distance there. Okay.
And based off of these equations, let me think. Okay, based off of these equations, we looked for the one that's the most convenient, and we went through this one. We have velocity initial. We don't have velocity final, so that means we have to go find it. We have time. We have velocity initial. We have the acceleration, but we don't have the distance, which is what would, well, we don't have the velocity final, so we can't find the distance in this case. And for this one, we're looking for this. We have the initial distance. We have the initial velocity, the time, and the acceleration. So we have everything we need here. We don't need to go through any other steps to find the distance we're looking for at this time. So
Okay.
now we have an equation that has everything we need. We just need to plug in numbers now to find distance, find the final distance in this case.
Okay.
Hello, is this thing on?
No,
Yes.
Bruh. Wait, did you guys go over number 6?
Which one's number 6?
I think we skipped that.
You guys skipped it?
Wait.
Perhaps. I do not have access to the send gauge, so if you can screenshot it and send it to me, or take a photo of
Oh,
it,
if I can screenshot it.
yeah, and send it to me.
Yeah, we skipped number 6.
Say last slipping tool.
Okay, so Matthew, continue. If you can find the distance at
I
1
forgot
second.
what I was saying.
You're good. Just try to find the distance at 1 second given at the time.
It's fine. Acceleration. What's the, oh, yeah, 4.48.
Matt, you find that final what's it called final distance yet?
Squared. Is it 9.96?
No, it wouldn't be 9.
Uh,
What numbers
I
did
did
you
it
plug in?
wrong.
What did you plug in for initial velocity?
As 0? Wait, no. I wasn't supposed to put that, right?
No, velocity. The initial velocity is 0. You're correct.
Oh, okay.
Times the time, which
So
multiplied by 0, 0, times 1/2 at squared. I'm gonna go ahead and write this out. So in this case, the initial position is 0 meters. The velocity at the initial point is 0 meters per second times the time, which is 1 second, plus 1/2 the acceleration, which is 4.48 meters per second squared, times the time squared, which is 1 squared. So get rid of this. You can get rid
Oh,
of this.
I didn't square the 4 point. I think the square messed up.
No, you don't need to square 4.48. You are squaring the time, not the
Oh,
acceleration.
okay.
So
Okay.
That 4.48. Basically, this boils down to the acceleration times time squared. Oh.
2.24.
2.24, that is correct. 2.24 is correct.
Yeah. Okay.
You're good. It's okay. So now we have 2.24, which if we gauge here, let's say this is 8, right? 8, divide this into 2, this is 4, divide this into 2, this is 2. We got 2.24, which is right here. And you see how this
Yeah.
is not linear.
Okay. So it has a curve.
So what we're going to have is a curve. That's basically what I was trying to drive here. If you have, in this situation where acceleration is constant, velocity will be linear, will be increasing linearly, and this one will be increasing at a curve. I'm not. I think this is quadratically. Yeah, this will be increasing quadratically. So, if you look at the question, let's see. Okay. So if you look at the question now, you'll see that you'll be able to, if you look at the question and you're looking at which one to choose, you could then, you now have the values 2.24 at 1 second and 7.58 at 1.84 seconds. And you can use that to select your answer. You know for sure, at least in your case, it's not
Okay.
B or C. Right?
Yeah.
Okay, so for
I
sure it's
think it would
either
be.
A or D. We'll just need to decide which one that is.
I think it'd be A.
Let me go ahead and move on to the next question. Azul, I'll go ahead and
Yes.
onto your Namundo of her garage with a constant acceleration of 1.3 meters per second squared. How long does it take her to reach a speed of 2.2 meters per second? Matthew, because we went
Yeah.
over a similar question, I'll just be directing most of my questions towards Azul, because I feel
Yeah.
this should be kind of familiar to you, given the kinematic formulas.
Yeah.
Okay, good. All right, so how long does it take her to reach a speed of 2.2 meters per second? Azul, do you know your kinematic equations for physics?
Of course.
Okay.
They are. It is V equals V naught plus A times T.
Okay,
Yep.
that's it.
The other one is X equals X naught plus B naught T plus 1/2 AT squared.
Uh-huh.
And then V squared equals B naught squared plus 2A times the delta X.
Mhm.
Sir.
Okay, so that's basically it. That's most of them. This is the one that I use often. At least I see this used often. Velocity. She may not have told y'all. No, this is not velocity. This is X. Yeah. Velocity initial or V naught plus velocity final times T. Okay, so we got all that. She may not have told you this one. It's okay. If she didn't. But you may want to write it down because these kinematic equations will be your key in finding out values. For example, if you are given a time, right? You're given your time, you're given your final velocity, and you're given your initial velocity. You can use this equation to find acceleration with algebraic manipulation. And that goes for any of these equations. If I give you x, the initial velocity, and some other stuff, you'll just underline which ones you have. See if you have the goal is to have only one variable unknown so that you can solve for that variable. So in this case, what are we given in this question? What are we given?
Constant acceleration.
So
And how long does it take her to, and the speed?
which one? Velocity initial or velocity final?
Final, right?
That's correct. Yeah, that's correct. All right, so we have that. So based off of these things, which equation could we use?
Let's see. Using my brain, I
Hopefully.
think. Okay. Um, uh, the first one,
The first
the
one is
last one.
the last one.
Oh, the first one. Yeah.
Yeah, the first one. It would not be the last one because we're only given velocity final. That means that this one, well, we know velocity initial. And far back out of the garage.
0.
Yeah, 0. Time is unknown and distance is unknown. This one,
Oh, okay.
acceleration, and so on. You get the point. We have acceleration. We have
Yeah.
velocity final. That leaves, and we have velocity initial. That leaves only one variable unknown, which is t. So go ahead and plug
Yes.
in numbers and manipulate the equation so that you can solve for t. Come back to me when you have an answer.
Wait, would velocity be the speed?
Velocity in this
Yeah,
case
right?
would be speed. Would be speed. Velocity,
Okay.
speed, sometimes they're interchangeable depending on the context. In this case, you can. You'll learn which, you'll get a feel for it as you do more problems, which, when you can use velocity for speed and speed for velocity.
Okay. Okay, I've plugged it in.
Alrighty, what do you get for time?
Oh, you want me to solve?
Yeah.
Hold on.
Yeah.
Hold. 2.2 divided by 1.3. Is it 1.69?
That is correct.
Seconds?
How many significant
Yay.
numbers are we using?
3.
That is correct. That is correct. Awesome. So now you have your answer for that one. T is equal to 1.69 seconds. Okay, so let's move on to the second one. Then if she then brakes at a stop in 0.8 seconds, what is her constant deceleration in meters per second squared if she then brakes to a stop? Okay, so this is after she has accelerated to that speed of 2.2 meters per second.
Uh-huh.
Okay, do you know the formula for acceleration?
The formula for acceleration is delta V over delta T.
Delta V over delta T. Yeah, that's basically it. That's all you need for this question.
Ah, okay.
Yeah.
Okay.
As I
So then
told
plug
Matthew,
in.
this stuff is weird. You won't know exactly what to do. I've developed instinct over a grievous number of physics questions I've answered in my physics career. So you'll develop it as well, but it will take some time. Be patient with yourself and
Okay.
do problems over and over again.
Okay. Okay, so then plug in the change of okay. T final. Wait. So would you add it?
Add. What are we adding?
Wait, walk me through, bruh.
Okay. So the change in velocity. Okay, so let's imagine what's going to
Mhm.
happen here. If she brakes to a stop in 0.8 seconds, she brakes to a stop.
Mm-hmm.
She brakes from being in
Yes.
motion. What was her rate of motion? What was her rate of velocity at the very beginning?
It was 2.2.
2.2 meters per second. That is correct. What is her final velocity after she's braked to a stop?
0.
That is correct. So if we find the difference between those, we have the change in velocity. What is, how long did it
Yes.
take her to brake to a stop?
0.8 seconds.
0.8 seconds. That is correct. And now you have everything you need to solve this.
Oh, okay. I was
See,
trying to add the 1.69.8 seconds.
right, no, yeah, no need for that.
2.75.
2.75. That is correct. The what are the units for this number? 2.75.
Meters per second squared.
That is correct. That is correct. If you divide speed or velocity by time, which is meters per second divided by seconds, you end up with meters per second times seconds, as we know, is meters per second squared. Well, you'll be able to see that when you do that. You were talking about adding 1.69 to 0.8, and I can see why you wanted to do that, but you have to keep in mind this change in time is dependent on context. The context here is that she braked to a stop in 0.8 seconds, and that's
Okay.
it's always across that time. Not it doesn't include the time that she took to accelerate 2.2 seconds meters per second.
Okay.
Yes, awesome. Alrighty.
I see.
For y'all's sake,
Okay, thank you.
this is supposed to end, but for y'all's sake, I will extend until maybe 4:30. My stomach is yelling at me. There's physics problems making me hungry. But damn, what's this? Matthew, which question? You sending me 9, 8, and 9?
Yeah.
Bro, he just wants his homework done for it.
Okay, I understand. But as I said, I'm not supposed to do exactly your homework, but for the case of
No, yeah.
understanding this, I will do that. But for your sake, you need to do these questions again
Learn.
so that you
Yeah.
learn the process of breaking down a physics problem and solving it. Okay, so
Question.
okay,
Will you be posting the recording?
I'll be posting the recording except for that part later
Uh-huh.
tonight.
I think that part will still be it.
Oh no, man.
I hope so. I hope you forget. I hope you forget.
You hope I forget. You know, just for that, I'll write it down.
I expect a Starbucks apology Wednesday.
Apology.
Yeah, I'll take a caramel ribbon crunch frap. Thank you.
Yo, ass is tripping. I'm not buying you crap. Anyway, let me see.
What?
Let's see.
Uh-huh.
A bicycle racer sprints at
I'll,
the. Huh?
I'll be leaving then.
You'll be leaving them?
That was the only question. Yeah, that was the only question I was stuck on.
Okay, no problem. Before you leave, can you drop your ID number in the group chat?
Yes. In the group chat or in this chat?
My bad. Let me rephrase that. Yeah, in the
Zoom one?
Zoom, yeah, the Zoom chat. I'll be using it for
Okay. What's this
attendance.
for? Ah,
What?
okay, okay. Okay, thank you, bye.
No problem. Adios. Stay safe. Okay, so we have. Let's see.
I think I'm good for now, honestly.
Okay. Okay. If
Yeah.
you have any questions, like small questions that I could possibly answer over
Yeah.
over GroupMe, go ahead and shoot me a text. I will respond whenever I can.
Okay. All right. Thank you.
Alrighty. Take care, Matthew.
You too. Bye.
Adios.